Hey everybody, thanks for joining us. And for this presentation, we're going to look at the effects of dosage-adjusted resistance training on a mouse model of dysferlin deficiency. This was presented by myself, Drew Mankowski, alongside Robert Kamai and Nicholas Murphy. And this includes Drs. Pepin, Blackmere, and Roche. So what is dysferlin deficient muscular dystrophy? Starting with muscular dystrophy, what this refers to is a group of inherited diseases that results in progressive muscular weakness and muscle loss. And then moving on to dysferlin, what dysferlin is a protein that is closely associated with muscle fiber cell membranes. And although the exact function of dysferlin is not known, muscles lacking in dysferlin tend to be significantly delayed in healing following an injury. So this damage in muscle begins hours after eccentric contractions and any excessive stress that is put on the muscle, and can continue for several days. So taking a look at the picture here, what we see is that in the posterior compartment of the leg, you can see that the calf muscles have a fair amount of atrophy. As mentioned previously, eccentric contractions tend to have a substantial harmful effect in terms of muscle damage in dysferlin deficient animal models. And if we look at the same animal models with unloaded concentric exercise, what we see is that unloaded concentric exercise does not result in muscle damage within these muscle fibers. So in that case, we can say that unloaded concentric exercise is protective against muscle damage. So what we looked at is whether or not loaded concentric exercise with that resistance of 50% of a 1 rep max would produce muscle damage in dysferlin deficient mice. And the reason that we wanted to look at resisted muscle training is that resisted muscle training helps build strength, and there is currently a lack of research involving this resisted muscle training and its ability to protect against eccentric and damaging contractions seen in dysferlin deficient muscles. Moving on to our methods, what we did is we split dysferlin deficient mice into two groups, one being a concentric exercise group and the other being eccentric exercise. And from there, what we would do is test the 1 rep max of the tibialis anterior muscle, and then perform a single bout of 40 concentric contractions at 50% of that 1 rep max that we determined in the concentric group, or we would do 40 eccentric contractions for the eccentric group. And from there, we euthanized the mice 3 days after that exercise bout, collected the exercise and unexercised tibialis anterior muscles of these mice to determine what sort of muscle damage had occurred. Depicted here are our results, and if we start with the images on the left, we'll split that up into a left and a right column. And in the left column, these are your healthy, uninjured, unexercised muscles. And then in the right column, these are your concentric and eccentric groups. So that top right is concentric, bottom right is an eccentric. And if we look at the left column compared to the top right image, the concentric group, we see that all three of these images are quite similar. So we can say that the concentric muscle group did not result in any additional damage compared to the eccentric muscle group. Because if we look at the eccentric group exercised, we see that this is very different than the other three images. Based on the white space where the asterisks are, we say that this is where muscle damage has occurred and where swelling is happening. And if we look at the graph on the right, we're looking mainly focusing on that right column, that column in red, that's your eccentric exercise. And this is based on the larger that column is, the more damage that occurred in that muscle. So since that column is the largest, we say that eccentric contractions resulted in a massive amount of damage, whereas that concentric contraction did not result in damage compared to unexercised muscle. Based on the results from the previous slide, we can determine that resisted concentric exercise does not result in muscle damage. So then additionally, what we want to look at for future research is to determine if this exercise can protect against the damaging eccentric contractions that we saw on the previous slide. Additionally, we want to add female mice, as we only looked at males for this. And then we'd want to look at that optimal load that would provide a practical strengthening benefit while also protecting against future injury. Noted here are our resources, and thanks for joining us.